Today we're going to talk about the Honors Algebra 2 Edgenuity section 7-1 called Negative Exponents. We have two objectives for this section. The first is to evaluate numeric expressions using the laws of integer exponents. And the second is to simplify single variable expressions using the laws of integer exponents. So everything we're going to do today deals with the laws of integer exponents. So I'll be talking about that fairly extensively. Let's look at a sort of simple beginning problem, although we need to talk about the definition of that symbol of division and how to make this a more coherent problem, because we actually get bogged down by that symbol. So I'm going to put up two things. The first is that division is multiplication by reciprocal. So that is the definition of what division is. Division is a form of multiplication. It is multiplication by reciprocal. The second thing is that the reciprocal of a number, the reciprocal is the opposite sign on the exponent. So if I want to talk about this problem in terms of a multiplication problem, and it's almost always easier to do that. There are some things that I can do. I can say that this is the same as 4 to the second times the reciprocal of this one, and I could write the reciprocal in two different ways. I could write it as 1 over 4 to the sixth. That's another definition of the reciprocal, is to do it that way, and then you would have 4 to the second over 4 to the sixth, and you could say that is like having 4 times 4 over having 4 times 4 times 4 times 4 times 4 times 4, 6 times, and you could cancel a 4 there, you could cancel a 4 there, and you could have 1 over 4 to the fourth. That is these 4 4s right there. And you could certainly do it that way, but there is another way of doing it, and the other way of doing it is to say this is 4 to the second times the reciprocal of 4 to the sixth, meaning 4 to the negative sixth, the opposite sign. Since this is a positive 6, we change it to a negative 6. And 4 to the negative sixth means that right there. So that is these are all saying the same thing with slightly different syntax, okay? And then you could use the integer exponent rule that if you have the same bases and you are multiplying, that you can then add the exponents. And then you have that 2 plus negative 6 is negative 4, so you have 4 to the negative fourth. And so this is a perfectly good answer. This is a perfectly good answer. And you could change this to this negative right here. It means 1 over all of this. So 1 over 4 to the 4th, so then we have that same thing. And then you could put it into a calculator and figure out what 4 to the 4th power is, which is like 16 times 16, which is 256, maybe? Well, I think 256. So I might be wrong about that, but so somebody might want to check my math on that. But as long as that's the correct number, all of those are acceptable versions of the correct answer to this division problem. I'll pause for a moment to let you look at that, see if you've got questions. Okay. Let's move on to another one. So now this is that same problem, and we're just pinning it down to that one little bit. So 4 to the negative 4th, I could call 1 over 4 to the 4th, which is a perfectly acceptable way of representing it. And I could call it, let me figure out what 16 times 16 is, and we'll be sure. I'm pretty sure it's 256, but let's see, that would be 36, carry the 3, that would be 9, 0 placeholder, 6, 1, 6, 5, carry the 1, 256, so 1 over 256. That's what I thought. But sometimes it's good to just check on paper and be sure. So these are perfectly acceptable ways. Each of those is a perfectly acceptable way of writing that. I'll let you look at that, see if there are questions. Okay, moving on. So this is the same flavor of problem. I have the same base. Now, properties of exponents tell me that if I have that same base, I can write that base and I can add the exponents as long as I'm multiplying the two things. So because it's multiplication right there, that's the reason I can talk about this, I can do 5 to the 3rd times 5 to the negative 7th is 5 to the 3 plus negative 7. And 3 plus negative 7 is negative 4, so this is like 5 to the negative 4th. And 5, so there's one version of the answer, and 5 to the negative 4th is like 1 over 5 to the 4th. And then 5 to the 4th is like 25 times 25, which I believe is 625, but let's do the paperwork and double check. That's 25, carry the 2, that's 10, 12, 0, 2 times 5 is 10, carry the 1, that's 5, so it is indeed 625. So this is another perfectly acceptable answer, and then another perfectly acceptable answer is 1 over 625. So all of these are good answers. I'll pause for a moment to see if there are any questions. Okay, there being no questions, I'll move on. All right, let's talk about simplifying this one. Again, same idea. I'm multiplying two things with the same base, which means I can take that base and I can add the exponents. 4 plus negative 5 is negative 1, so that's 6 to the negative 1st. So this is a perfectly acceptable answer. That's also 1 over 6 to the first. There's another perfectly acceptable answer. And then 6 to the first is 6, so this is just 1 over 6. And there's another perfectly acceptable version of the answer. Okay, and the reason this works is because this is like saying 6 to the fourth times what this means, which is 1 over 6 to the fifth, which when you multiply those two, you get 6 to the fourth times 1 is 6 to the fourth over 6 to the fifth. And if you need to see that visually, that's like 4 6s multiplied together on top and 5 6s multiplied together on the bottom. And then you can cancel a 6, cancel a 6, cancel a 6, cancel a 6, leaving you with nothing on the top and 1 6 on the bottom. So that is sort of the explanation behind things. I'll let you look at that for a moment, see if you've got questions. Okay, there being no questions, I'll move on. So let's talk about a different property. This is what happens when you raise powers to other powers. So we've got a power here, raising it to another power there. And when you have this, then you take that base. Notice there's only a single base here. You take that base and you multiply the two powers. So it's 10 to the negative 2 times 4, which is 10 to the negative 8th, which is 1 over 10 to the 8th. And then 10 to the 8th is actually easy to do. 10 to a power shifts the decimal from 1.0 that many times. So 10 to the first would just be one place, and so 10 to the first is 10. But if we've got 10 to the 8th, then we need 8 places, so 2, 3, 4, 5, 6, 7, 8. So that gives you 8 zeros. And then you just got to put in the commas. 1 there, 1 there, and so you have 100 million. 100 million. Like that. If you count, you'll see that there are 8 zeros. Okay? I'll pause here for questions. Okay. There being no questions, I will move on. And again, so I did this already, but I'll do it again. It's 1 over 10 to the 8th. The negative is why I know it's 1 over. The negative tells me it's the reciprocal. And then 10 to the 8th is a 1 with 8 zeros. 1, 2, 3, 4, 5, 6. Or 1, 2, 3, 4, 5, 6, 7, 8. All right, I'll pause for a moment for more questions, although we just talked about this. Okay, there being no questions, I'll move on. Now let's talk about it. What happens if I put in variables with this? Well, the nice thing is that nothing really changes. There are two ways to do this, and I'll partition this so we can see the two ways. You could have a squared over a to the ninth, and then you could say, okay, that means a times a at the top, and then 9 a's multiplied on the bottom. 1, 2, 3, 4, 5, 6, 7, 8, 9. I think that's 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes. And then you could do cancel, 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 which would give you 1 over, and then you'd count there are 7 a's left. And you could either leave it that way, or you could say that's the same as a to the negative 7th, the negative meaning 1 over. So that's one way of doing it. The other way is to say, hey, look, I've got a division problem. Let me change that division, this division problem here, let me call it multiplication by reciprocal. So that's a to the second times a to the negative 9th, which is the reciprocal of a to the 9th. And then you've got the same bases, and you're multiplying, so it's the base and add the exponents, which gives you a to the negative 7th, which you might also write as 1 over a to the 7th. I'll let you look at that for a moment and give you time for questions. Okay, there being no questions, I will move on. All right, so let's mix it up a little bit. Let's throw numbers and letters into here, numbers and variables into here. So I want you to notice something. This is negative 3 times b to the 4th times 6 times b to the negative 8th. It's all multiplication. What's nice about that is if it's all multiplication, I can do it in any order that I want. So I can rearrange this. Let's do negative 3 times 6 times b to the 4th times b to the negative 8th. So I'm going to collect things this way because then I can do this, and I can do this separately, and then I can put them together. So negative 3 times 6 is negative 18. And then b to the 4th times b to the negative 8th is the same base. So I would keep the base and add the exponents, as we've been doing for a lot of these, because I'm multiplying same bases. So then that's negative 18 times b to the 4 plus negative 8 is negative 4. So of course you could keep it that way, or you could say that's negative 18 times 1 over b to the 4th, which is negative 18 over b to the 4th. So this is a perfectly acceptable answer here. This too is a perfectly acceptable answer. I'll pause for a moment, let you look at that, see if you've got questions. Okay, there being no questions, I will move on. So let's do that again, except for now we're going to start with division. So here's what I would say. Don't use that. Always rewrite it as a fraction, and then look at it again, because as a fraction you might be able to see some stuff with it, okay? So let's write this as 21 v to the negative 6th over negative 7v to the negative 6th. Now, the reason I like looking at it this way is because when you look at fractions, if you've got a thing over itself, then you're good, right? You can just cancel them. For example, these two things right here, v to the negative 6 over v to the negative 6, those just cancel. That's just 1, right? Assuming that v isn't 0, of course. And then 21 divided by negative 7, well, a positive divided by a negative is a negative, and 21 divided by 7 is 3. And that's it. You're done with that one. Now, you could have been a little more careful, and it's somewhat interesting to see this done in a slightly different way, which is to isolate the two fractions. Say 21 over negative 7 times v to the negative 6th over v to the negative 6th, and then this part, of course, is still negative 3, but then if you treat this as a division problem that you're going to turn into a multiplication problem, you could say that's v to the negative 6th times the reciprocal of v to the negative 6th, which is v to the 6th. Meaning now, again, you've got same bases and you're multiplying. So that's like v and add the exponents, which gives you negative 3 times v to the 0 power, which then should illustrate pretty fundamentally why anything to the 0 power other than 0 is 1. Because how did we get that? Well, we started out with a version of 1, right? We started out with a thing divided by itself. And of course, it's still negative 3. So, just wanted to show you that to kind of illustrate that idea that something to the 0 power is 1, because the way you get 1 is by having the thing over itself and then adding the exponents. I'll pause for a moment to see if there are questions. Okay, there being no questions, I will move on. So let's start out, let's go to something a little more complicated, which is we're going to look at how to do something like this, okay? So the first thing I would say is reduce what you can in the fraction. Deal with the fraction as much as possible. For example, I've got 20 divided by 10. Like, I'm just going to make that 2, because it's really easy to just make that 2. I've got this x to the negative 3rd over x to the negative 1st. And again, I can sort of think of these as separate because it's all multiplication. And that's the only reason I can think of them separate. The moment that I start having addition and subtraction in it, then that doesn't work anymore. So 2, which I got from this, times x to the negative 3rd over x to the negative 1st, and then all of that is being raised to the 2nd power. I'm going to have to start writing a little bit smaller here, but we'll be able to do that. So that's 2 times, and I'm going to take this, and I'm going to turn it into a multiplication by reciprocal problem. That's x to the negative 3rd. That's a terrible 3. X to the negative 3rd times x to the 1st, because that's a reciprocal of x to the negative 1, is x to the positive 1. And all of that still raised to the negative 2nd power. So then that's 2, and then add the exponents, because I've got a like base and I'm multiplying. So that's x to the negative second, and then all of this raised to the negative second. So now I've got something quite a bit easier. Now the other rule is that as long as it's only multiplication in here, I can take this and distribute it. But I can only do this as long as the inside is all multiplication. Okay? So this can be 2 to the negative second times x to the negative second raised to the negative second power. So then it's 2 to the negative second, and when you raise powers to other powers, you multiply the powers. So we've got 2 to the negative second times x to the negative 2 times negative 2, which is positive 4. And that's a perfectly acceptable way to write it, but I could also say, okay, this 2 to the negative 2 is the same as 1 over 2 to the second, so this could be x to the fourth over 2 to the positive second, which would be the same as x to the fourth over 4. So that is another way to look at it. I will pause for a moment and let you look at that, see if there are any questions. Okay. There being no questions, let's move on. We're almost done here. Let's talk about simplifying this. So what I've got here is this fraction, which I can't do anything with this time, and I've got this negative in the exponent. The negative tells me use the reciprocal. So the reciprocal of 1/3 is 3 over 1. And then this becomes a positive because since I've taken the reciprocal, I've used up that negative right there. And then 3 over 1 is 3 divided by 1 is just 3. And so I've got 3 to the fourth. And then 3 to the fourth is 3 times 3 times 3 times 3, which is like 9 times 9, which is 81. I'll pause again, let you look at that, see if there are any questions. When you're dealing with fractions, the reciprocal of a fraction is that fraction flipped over. So if that negative is telling you to take the reciprocal of a fraction, just flip the fraction over. All right, there being no questions, I will move on to our final question. What is the quotient of this? Quotient means the answer to a division problem. But I don't like it as a division problem. I'm going to turn it into a multiplication problem. That's going to be 5 to the negative 6th times the reciprocal of 5 to the negative 4th, which is just 5 to the 4th. And now I've got the same bases. So I can turn this into one base, and add the exponents. And then negative 6 plus 4 is negative 2. And that's like 1 over 5 to the second, which is the same as 1 over 5 times 5. Which is 25. And again, this is an acceptable answer, this is an acceptable answer, this is also an acceptable answer. I'll pause here for a moment to see if there are questions, and that will be it for this section. Thank you.